So I'm going to divert a little bit from the agenda and ready to go? There we go. Actually talk about sort of trophic connections in Lake Ontario fishes. I'm not going to stick strictly to the salmonids because I think there's a sort of a bigger picture, and as Dr. Johnson laid out incredibly well yesterday, a lot of our work, especially with our 2013 work with a CSMI, is trying to link lower trophic levels to sport fishes, and it just seems incredibly obvious to use fish diets as a way of understanding those connections. But beyond that, another thing that we're trying to do is, as the system is changing, we're trying to parameterize mass balance models. If you're familiar with Lake Ontario, Tom Stewart has put out some recent models in time periods, and we want to update some of those. So we want to parameterize those mass balance models and food web energy flows. We need to actually use the fish diet information to do that. And finally, if you think about history, there's always people doing fish diet studies, right? Here, an artist rendition of O'Gorman and Bergstead out on the first food web habit study in Lake Ontario. Thank you, Jim Johnson, for stealing my thunder for using that kind of slide. But the history really gives you the context. And so while a lot of what we're doing is 2013 focused for parameterizing the models, without acknowledging all the prior work of these individuals and trying to pull those data together, you can't really get a context for how things have changed or how much that change has actually mattered. So the data sources are coming from all over the place. Once you start building it, sort of seems like fish diet data just keeps flowing in. Much of the work for 2013 was thankfully funded by the EPA and Fred Luckey out of Region 2 when we lost some of our GLRI dollars. He stepped in, and he and Brian Lantry did some excellent figuring and made sure that this was an important part of our CSMI work in 2013. So, we're going back as far as some Brandt and Rand data in Lake Ontario, trying to pull those data back into a time series. Jana Lantry's master's thesis work in 98 and 99. All these data sources used angler caught fish, so stomachs of Chinooks and lake trout, rainbow trout and browns from angler caught fish, as well as some data from Mike Connerton in the early 2000s, and then our work in 2013, which was both angler caught data and gillnet data. This time series is not complete. There's also data to be included from a variety of OM&R data series and efforts. So this is definitely it's the first cut at some of this information. We also did some nearshore work, so that was new too. To that, previously everyone was focused on the salmonids. In 2013, we wanted to look at sort of the role of smallmouth bass, walleye, and perch and what they were feeding on. Similarly, prey fish diets, Maureen Walsh and I have been collecting diet information over the years since 2010, and so getting a seasonal look at prey fish diets in Lake Ontario, and as well as vertical gillnet diet data from 2013, and Tom Stewart and OM&R is also contributing a lot of data to that as well. So I'm going to hit on just a couple topics here, sort of broad brush to the time series. I'm going to talk about the lake, the Chinook and alewife connection, and make some references to some recent work published in Lake Michigan. Talk about the rest of the salmonid diet and what those look like. Hit on round gobies prevalence in piscivores and see where we think that food web connection is likely to be important, and then tie that fully more completely into prey fish diets. So Jana flashed a preview to this slide, but it's alewife, and sometimes the Chinook eats alewife. Really, through the time series, it was a little bit, it was a little sad after putting all this data together and plotting it the first time, being like, wow, it really doesn't matter. Much like some of the literature says, they're an incredibly efficient predator on alewife and will choose alewife. An important thing to reference, though, is during periods when rainbow smelt, if you remember from Maureen's talk, peak abundances of rainbow smelt were in those mid to late 80s. That's when they did appear in any measurable proportion in the diet. Obviously, these are zeros for round gobies. That number is slightly above zero. We can think about size and its influence on these piscivore diets. I'm using 500 millimeters here just because it seems to be a fairly common break that's been used in other analyses. Chinooks greater than 500 millimeters, really key in on those alewife. And the gobies that we did find were in these smaller 400 millimeter size. We did find gobies, 2 instances of a goby in a Chinook diet. So when the anglers ask me, I can say, yep, there were 2 out of a couple thousand looked at. Also, rainbow smelt, some of these alternative forage species are likely to be more prevalent in the smaller age classes or the smaller sizes of Chinook salmon. As I mentioned, a paper by Jacobs et al. Looked at the Chinook foraging patterns in Lake Michigan, and saw 2 really important things. One, in the recent diet, they saw very similar trends to what we're seeing: large alewife, large Chinooks eating alewife. Smaller Chinooks will take advantage of other species. So in this case, bloater actually make up about 15% of the diet by dry weight. They also saw a shift in the alewife size distribution, and that was reflected in the consumption in Chinooks, where back in the 90s they were eating a much larger size alewife. Now that those alewife aren't actually out there or as abundant in Lake Michigan, they're preying on smaller alewife. We ran a similar analysis in our data and find actually no trend. It's about a 148 millimeter alewife that they consume, plus or minus 1 millimeter. And so that's been remarkably consistent, which fits with very few trends in our alewife size distribution. We really haven't seen anything changing out there. But these are just some of the things we can actually address, look at, and inform ourselves with data now that we're building these time series. Other salmonids, the picture's not all that different. It's still an alewife dominated system. Yes, rainbow trout eat a more diverse diet in the lake. They're feeding on terrestrials, but when you take it by dry weight, it takes a heck of a lot of ants to equal the weight of 140 millimeter alewife. Similarly with coho salmon, a little bit more diverse. We do see some of the minnow species, mainly emerald shiners, so maybe that's they're catching the last few emeralds out there that our trawls can't. And then the story starts to change when we move to lake trout. And again, I'm representing everything here. On the x-axis is diet proportion calculated by dry weight. For lake trout, round goby are now, in just our 2013 data alone, we're making up 10, 15%. But in brown trout, that proportion was over 40% of their diet. And these are collected from the early spring, when they're more abundant, all through the summer, and then again in the fall. And that was the pattern we saw. There were round goby throughout brown trout diets throughout the year, but they were most prevalent in the spring and the fall time periods. So thinking a little bit more about that, we pulled the data just from our nearshore fishes, and that was even a little bit more surprising. We knew they were consuming goby, but just what those percentages were by dry weight were pretty astounding, that 80 to 90% of smallmouth and yellow perch diets are round goby. Even about 20% of the walleye we're finding round goby in. So this is a good slide, just sort of demonstrating the efficiency of some of these predators in the early spring, where brown trout, in this one I think it was something like 29 round goby in one stomach, plus a bunch of unidentified fish that were also likely round goby. So it's an important food web pathway, and it's one that I don't think anyone is surprised at, but really trying to quantify the magnitude of it is one of our goals of our USGS broader GLRI project. So, to connect that to lower trophic levels, we have to look at the prey fish diets. So here, these are information from the past 3 years, all aggregated together across seasons. And what we find is the actual dry weights, not the shell, but the dry weight of dracenids make up about 70% of the diet of a round goby. So these are main lake caught fish. There's been some work in the Great Lakes in summer near shore and tributaries, in embayments where benthic invertebrates make up a big proportion. But if you saw Tim's talk, there's not a lot of other benthic invertebrates out there for round gobies to be consuming. So dracenids are sort of the number one diet items. This might be a little bit surprising as well to see mysis, a cold water invertebrate showing up in such a high proportion in the round goby diets. But it's important, one thing that we certainly see and observe on the South Shore in our trawls is that round goby are not just a nearshore fish, as a lot of folks think of them as. It's when you see them. When we go out and trawl in April, June, and October, we see starkly different densities associated with depth. In April, the peak density of round goby, biomass density, is around 100 meters. So that's actually where we find the warmest water on the bottom. That's where we're seeing the highest densities of round gobies, and there are a lot of them spread out across that area. So April, we're almost thinking of as sort of a winter distribution. By June, really that's in April, May, and then by May, June, 1 month later, all of those fish are almost outside our detection. We can only trawl into about 5 or 8 meters. They're up tight to shore, very shallow, so that movement occurs quite rapidly over that time period. And then when we get out again in October, that distribution has started to shift back out again. So it's occurring anywhere from 30 to 50 meters of depth. So from that time, October to April, 7 months, you're actually overlapping quite well with mysids. And if you're thinking about diets across that entire time period, mysids actually start to make a little bit more sense in the goby diets. That didn't pop out. There we go. One important thing, sorry about this, we saw some interesting questions that Tim asked about alewife consuming cyclopoid copepods and the interaction with Bythotrephes. So we pulled up the alewife diets as well. As predicted, in a year when Bythotrephes are low, cyclopoid copepods are quite high in the lake, and the alewife diets are reflecting those. Sorry, I pasted over the sort of the neat other point was that we're also seeing a couple round goby, juvenile round goby in alewife diets. This was surprising at first, but Todd Hayden and Jeff Miner did some work in some recently published Lake Erie work thinking about the behavioral and the vertical migration of these very small juvenile round goby moving up in the water column at night, which is what they found. It was a very nocturnal behavioral pattern, but they are moving up at night to feed on plankton. And so, seeing these things, seeing these gobies in alewife is actually starting to make sense. I think there's also some evidence of juvenile salmonids in Lake Ontario taking advantage of those same very small goby. So, just another interesting twist on the food web, using fish diets to think about those linkages. Finally, if we go to rainbow smelt, slimy sculpin, and deep water sculpin, this is an idea that Tom put forth in a bunch of his modeling work, that a whole lot of the lake food web and the fish food web community is moving through mysis. In all of those cases, mysis are making up 80%, 60%, 80% of these fish's diet by dry weight. So another important piece to be thinking about. We wrap up. Chinook-like alewife still, that really hasn't changed. The non-alewife prey have to be abundant in order to see them. I'm not saying that some of these other species are not contributing to the diet, but at the rate that we can actually measure and observe the Chinook diet, you gotta have quite a few smelt or bloater out there to detect them in the stomachs. The influence of round goby is variable, minimal in Chinooks, rainbow trout, coho, more so in lake trout, very abundant in browns and very abundant in the nearshore fishes. Dracenids aren't a dead end. There's some thoughts in the ecological literature talking about sort of these trophic cul-de-sacs and where energy is not being utilized. I would actually propose that it's a more efficient manner of moving primary production to piscivores, because you don't have any intermediate trophic levels associated with mysids, predatory cladocerans, things like that. It seems to be moving from a primary production, dracenid, goby, brown trout. So a fairly simple trophic transfer of energy in that case. In this year, cyclopoid abundance was pretty high in the alewife diets. Those alewife diets were really a summer look at the diet. So as I said, this is just a first cut at what we have in students are working pretty hard on getting more of those diets, but mysids and predatory cladocerans, in this year, it was Cercopagus because, as we mentioned, Bithotrephes was quite low. And then everything else eats mysis. That was sort of a take home. So with that, I'll take any questions and then we can go to lunch.